So very good morning viewers. You are most welcome to this video lecture, and in this video lecture we will be covering on this artificial neural network, and we will be covering the part 2, that is the lecture 2. This is Dr. Jana and you are watching video with me. So in this ANN we already covered the introduction part, where we have discussed about the very introduction of this part. I think we can take it here. This is right place for this. So now we will be, so let me go for this, just take 1 minute. Yeah. So in this artificial neural network we can see the syllabus. This is we are following BR 18 for this JNTUK for this autonomous syllabus of BBC Engineering College. Here we are having 6 units. Unit 1 you are having the introduction, especially the neural network, the difference between the neural network and artificial neural network, the learning process, the perceptron, that is the ANN model. Then in unit 2 we are going for this multi-layer perceptron and the different algorithm like the backpropagation algorithm, and solving problem like a exclusive OR problem, then heuristics, output representation, solve things, then backpropagation. Then unit 3 we are going for the self-organizing map and all the details there. And unit 4 we are going for the recurrent network, the architecture, Hopfield network, Boltzmann machine, all things will be there. Then unit 5 we are having the adaptive resonance theory, ART1, ART2, like that, all things will be going there. And here we are also going for this PNN, like the probabilistic neural network PNN, and also radial basis function neural network RBNN. So these are things we are covering in unit 5. In the unit 6 we are going for this convolutional neural networks and all these related things, and we will be going for some algorithms like NNN, we will be going for CNN algorithm, we are going for the decision tree. If possible also some part of support vector machine also will cover. So this is the thing, and we have the textbook with us. We have a book, G. Jana, Dr. Gunamani Jana and Dr. R. Balyar Singh, an introductory course on artificial neural network, that is the Kindle publications, Amazon 2021. So this is the textbook, and the second book, Simon Heikin, this is the neural network, this is there, and the reference book, 2 books are there. So these are the things, and in this lecture outline you will have this introduction, that is the course introduction, and we can have the introduction to neural networks, uses in neural networks, simple neural networks like the perceptron, Adaline, multi-layer perceptron, basic dynamics, radial. These are the things we are going to cover. Fine. So now once again I welcome you, and let us see. We go for one. Just I think this is creating a lot of problem here. We can take it here. It is better. We can see the diagram of the artificial neural networks. If you minutely observe here, the two type of representation is the circular representation of nodes and the square nodes are there. Okay, these circular nodes in the artificial neural network, they represent the signal routing. That means they only take the input, they never participate in the processing part, right? So all the inputs are provided here. You can take it as x1, x2, x3 up to xn, and here this input we can call it as the input vector, because it is a single column values are there, so we can call it as a input vector. Similarly, you can see that one edges are there, arrow mark line, actually it is arrow mark is not there mentioned here. So here these are representation of weight. So it is Wij, weight from this node to this node, from I to j, Wij. So this is represented by weight vector, and their multiplication it becomes x into w, and they are processed by some activation function here. So the square nodes, they participate in the function. So after that we get the output, right? We get the output, so we call that the output vector. So this is the representation of our ANN. Then let us see the historical development of artificial neural network. It is not a new concept. You see, it started in 1890 when William James he describes in words and figures the simple distributed networks and also the Hebbian learning. He explained long back, 1890. Then Maculus Pitts, 1943, after a span of around 50 years, he described the binary threshold units that perform logical operations. They proved the universal computations. All the things it was done in 1943. In 1949, the formulation of physiological learning rule was done by Hebb, the Hebb's learning, most important is the Hebb's learning. Then Rosenblatt in 1958, after 9 years, he started the modeling like the perceptron, a fast real learning machine. Then in 1960, Woodrow and Hebb, so they developed the Adeline, or we call it the Woodrow-Hebb supervised learning rule. And just after that, we can see the evaluations in Conan in 1982. He developed the self-organizing maps. And Hopfield in 1982, the Hopfield networks. Then Rumelhart, Hinton and Williams in 1986, they proposed the backpropagation in the multilayer perceptron. Then Broomhead and Lowe in 1988, they gone for this radial basis function. And in 1990, the support vector machine, the latest it has come. So these are some of the things. These we have already covered our introduction part, like the ANN is biologically inspired. It is a computer program designed to simulate the way in which the human brain processes information. Then what it does actually, it gathers their knowledge by detecting the patterns and relationships in data and learn through experiences. It is not from this existing programming, so it learns from the things are like this, right? Then coming to the actual constituents of this ANN, it is formed from hundreds of single units. What we call it the processing units, or we call it as the artificial neurons or synthetic neurons. And the most beautiful thing is that they are all interconnected, or they are all in a network, okay, and they are organized in layers. And the power of neural computations comes from this connecting neurons in a network. So these neurons are the nodes, what we call it as the processing elements. What we call it as the processing elements. They have the weighted input. That means a input, and in the edges it is provided with a weight. We call it as the weighted input. Fine. And the behavior of a neural network is determined by the transfer functions of its neurons. Three things are there. One is the transfer function, then the learning rule, and the architecture itself. What type of architecture we are taking, based on that it is decided. Because the weights are adjusted, and this is the parameter, so we also call it as the parameterized system. The neural network, we also call it as the parameterized system. And the weighted sum of the inputs, weighted sum of the units, that means input into weight and their summation, we call it the weighted sum of the inputs. This constitutes the activations of the neurons, and the activation signal is passed through a transfer function to produce a single output in the neurons. So this is the principle on which it works. Then transfer function introduced nonlinearity to the networking, and during training the inter-unit connections are optimized until the error in the prediction is minimized or eliminated. Elimination is not possible, so we go for the minimization of that one. And once the network is trained and tested, it can give a new input information to predict the output. So these are the things. This is the part we have already covered, the difference between the biological neurons and the artificial neural network. So in terms of speed, processing, size, storage, fault tolerance, and control mechanism. So in our first video we have already covered these things. Then this neural network architecture is motivated by models of the human brain. So this part also we have covered. Then I was showing you the structure of these things. You can see this is the cell body, and here the central part is the nucleus, and here you can see the axons, and also the contact point here you can see this is the synapse or synaptic things. Okay, and this we can you see it here? The axons are there, all things are there here. Okay, in the previously I told the three things are there. One is the dendrite. Dendrite is the thicker part, we call it the dendrite. Okay, so the dendrite, then the axon, and the synaptic contact, where information is passed from one neuron to another neuron. So this is the representation of a single neuron. So imagine in the human brain there will be 10 to the power 11 number of neurons, and they are all are connected to 10 to the power 15 number of connections will be there. Okay. Then the most important part, we are going for the ANN model. So how do we go for this modeling? That is important for us now. So in the modeling, ANN is an information processing system, and it is just the synthetical or artificial neurons are called the processing elements. Okay, so I told you that this ANN is a processing system or information processing system. Then who process? The node or the artificial neurons who are represented, they participate in the processing of the elements. Okay, so a processing element processes local memory and carries out the location informations. Hence we go for this modeling the neural network. The memories are represented by circular and square nodes. I told you that the weights are applied across the arc. So the line is there, arrow line is there, and arrow marked line, and a group of neurons are arranged in layers, right? So the circular node takes the input. It is just like the it accepts the input. It does not participate in the computing, and the square, they participate in the computing, right? All the computation is done there. So each neuron simplifies outputs as weighted sum of the input. So suppose xi is the input, where I is equal to 0 to some finite number n, and wi is the weight from I to j. Then net output, which is equal to summation of xi into wj. So input and weight, their multiplication and their summation, that is represented as net output. So this is the concept we know. Then immediately it comes how we model these things. You see, you see some explanation is given here. In ANN, the inputs are conducted to the cell body. There are summed also, and some inputs tending to excite the cell, while others tending to inhibit firing. Okay, when the cumulative excitations in the cell body exceeds a threshold value, then we say that the information passes or the cell supposed to fire. So these are things. We see the model here. If you see it here, this is the input vector x, this is the weight vector which is applied on this arrow mark here on the edges, and their summation is done here, and finally what we find? We find the net output, which is x into w. Fine. Then this is the things which already you have done, and this is just I briefed you. In our lecture 2, we are going for this activation function. Say what is this activation and what are the different type of functions are there? Those are things we are going to discuss. Say in the first phase, the net output what we got, it is processed by a function, we call the function f, and the purpose is to produce the output. The net output was net, and the actual output will be OU2. This function which processes the net output to out, we call it as the activation function. Okay, and there are different type of activation functions we can discuss as below. Then in addition to this activation function, we are having another function, we call it as the threshold function. What is this threshold function? I'll tell you. So it is just, threshold is just like a factor which is used in calculating the activation of the given net, and based on the threshold the output can be calculated. So that means output is equal to function of this net. Say for example, suppose take t as a threshold value. If the net output is greater than t, then output will be 1. If it is less than or equal to t, then output will be 0. For example, I give an example here. Suppose we talk about the gradation system or the pass mark, minimum pass mark for any exam in JNTU or our some colleges, universities. So we say 35 is the pass mark. So threshold is t. That means if your mark is greater than or equal to 35, then you pass or it is 1. Otherwise, if up to 34 also you fail, that is 0. So that is just like that. So this threshold is not a fixed one. Say some university they fix 50 is the pass mark. That time the threshold will be 50, t is equal to 50. So like that, it depends on these applications, we can make it. Say here you see the threshold value it is given. See up to the threshold value it is 0. You see the two values are there, one is the 0 here and one is the 1 here. 1 means when it is equal to t, that means if you get 35 mark or more mark, then you pass. Pass is represented by 1. And up to 35, that means less than 35, up to 0 to 34, this is fail or 0. So this is the purpose of the threshold function. Then we also come across like some other functions like the signum function. These are also called quantized function. It is defined as, say for example, if you use that function, signum function, so you apply on the net output. So function of this net output can be +1 or -1. If the out is greater than t threshold value, then it becomes +1. If out is less than equal to 2, then it becomes equal to -1. So this we call a signum function. So the signum function is represented here. You can see it here. So if it is less than t, can you see it here? If it is less than or equal to t, then it is equal to minus 1. And if it is greater than t, then it is plus 1. So this is the signum function we are using. So like that we are having some sigmoid function. This sigmoid function, it has a S, just like S, English letter S shaped, and it is common form of activation function used in the artificial neural networks. It is an increasing function that shows linear and nonlinear behavior. So it is represented by a function fx is equal to 1 divided by 1 plus e to the power minus x, or sometime 1 divided by 1 plus e to the power minus alpha x. Okay. So in case our net output, we call it 1 divided by 1 plus e to the power minus alpha net. Here alpha is a slope parameter. Alpha is a slope parameter. Now we have some signum function is represented here again. Out is equal to function of net plus 1 minus 1. When out is greater than t or out is less than equal to t. Similar, the sigmoid function is equal to represented by 1 divided by 1 plus e to the power minus x, or 1 divided by 1 plus e to the power minus alpha net, that is the output. So where alpha is the slope parameter, just now I told you. So like that and another beautiful thing about the sigmoid function is that the first derivative of this function is equal to fx into 1 minus fx. So this is fx. If you want to f dash of x, then which is equal to fx into 1 minus fx. Then we are having a number of other functions. We have the linear function. Linear functions, y is equal to fx is equal to alpha x plus beta. When alpha is equal to 1, some thing, and beta is a constant. Okay, some slope or something like that. We are putting alpha is the slope. It's just y is equal to mx plus c, like something. So then we are having binary step function. In the binary step function, when x is equal to greater than or equal to theta threshold value, then it is 1. All other cases it is 0. So like that we can have, and you can see some other activation function here also. This is a sigmoid function. So I told you it looks like say S. So it depends on this alpha. So you can see it all like things. Similarly, bipolar sigmoid. You see, this sigmoid function, it is there here minus 2 to 2 x-axis, y-axis it is given 0 to 1. So all this representation we can do it here. But in bipolar, you can see it here, it is minus 1 to 1 in y-axis, and x-axis it is minus 2 to 2. So this is the 0, 0, and it will be at the center. Fine. So these are some of the different functions, and you can have another function, that is the identity functions. Yx is equal to x. That is, what is the value of x? That is y. See, for example, when x is equal to minus 2, y is equal to minus 2, and x is equal to 0, here y is equal to 0, and x is equal to 2, y is also 2. This we call the identity function. There are so many functions, just I am giving some idea about that one. Similarly, we are going for the step function. In the step, it is just like the steps you see in the staircases. Here, if x is greater than 0, if x is greater than 0, then yx is equal to 1, otherwise it is 0 here. You can see, same thing. Fine. So bipolar step function and all things you can see. Let us take an example. In this example, we will be able to understand all things. Let us take a small network here. I have taken x1, x2, x3 and xn. I have taken here because 1, 2, 3, 4 other I am taking 4. So x1 is equal to 0.9, x2 is equal to 0.7, x3 is equal to 0.5 and x4 is equal to 0.4. And here w1 I have taken minus 0.3, w2 is equal to 0.7, w3 is equal to 0.4 and w4 is equal to 0.6. Then how to find the net output? Net output is equal to x1 into w1. What is x1? x1 is equal to 0.9 and w1 is equal to minus 0.3. So 0.9 into minus 0.3 plus 0.7 into 0. This is 0.7 and this is 0.7. Like that you go for the multiplication and there sum is coming 0.66. So if I am putting in this sigmoid function, so output is equal to 1 divided by 1 plus e to the power minus. Again I am telling, output is equal to 1 divided by 1 plus e to the power minus alpha net. Alpha is equal to 1, I have taken it here. So net value, it is the 0.66. Putting all this value, it is coming 2.9347. So it is more than 1, so output will be 1, right? So in this way we can do. Then the final part, we are going for the neural network architectures. An artificial neural network can be represented using a directed graph G, and there are many classes of neural networks, and they are classified according to their learning machineries, right? So mainly they are classified into 3 fundamentally different classes. One is the feed-forward network, then one is the recurrent network, third one is the competitive network. So these are the 3 networks which you can come under. So they are represented mainly by three fundamentally different classes. One is the single layer artificial, so in the feed forward network, then is the recurrent network, and third one is the competitive network. In the feed forward network, we are having the single layer artificial neural network and the multi-layer artificial, or we call the single layer perceptron and the multi-layer perceptron. Then the second category of the network is the recurrent network, third one is the competitive network. So these are some of the things. So this is all about our lecture 2. I hope you people will enjoy this class, and if you like this class, please do share with your friends, and also don't forget to subscribe this channel also. So I hope you try to attend the classes, online classes what I am giving also. This is only for refreshing your memory what you are attending the regular classes. Thank you for watching this video. Once again, thank you.